Thank you. So our next speaker is Martin Ruckert from the University of Applied Sciences in Munich, Hochschule München. He is the main developer of the hint format that will be integrated into TeX Live next year. And this year he's on a full year sabbatical to work on that. However, as a result, it means that hint is a very much a moving target. So he'll be talking about something slightly different, but obviously still related to tech and more technical. We have a video. Tom, are you ready to show the video?
I should be ready, and I hope it will work directly within Zoom. So let's see how it goes.
Hello, I'm Martin Ruckert, and I talk today about the translation of TeX, the program, from web to cweb. To explain the why, I use KTeX as an example. It consists of TeX, of course, plus the extensions of epsilon TeX, plus the use of a 32-bit pointer type, plus the kpath search library for locating files. It's not a pure TeX, but a good compromise between staying close to Don Knuth's original program and meeting modern expectations. The first argument for a cweb implementation of TeX is the extremely simple toolchain, which I will demonstrate now. To get the documentation, I simply run cweave on KTeX and get a TeX file. I run TeX on the TeX file and get a DVI file. And this is TeX, the program as we know it, but using the programming language C. Now let's create the executable. I run ctangle on KTeX and I get ktex.c. Next, I run the C compiler gcc on ktex.c. I define init to get an inittex, and I can also define stat or debug. Then I need ktex.c. Now let's create the executable. And link in the kpath search library and the math library. And the output will be ktex. The compiler runs and we get the ktex executable. To use the ktex executable, we have to move it to the proper directory so that the kpath search library will find the input files. So I use install and move it to the TeX Live 2019 bin Windows 32 directory. I set the mode. Now it's at the right location and I can remove the local copy. The next thing I need to do is generate a format file. So I run ktex -ini to run it as inittex on bplane and I dump the result. I rename bplane.format to ktex.format. And I install it at the proper location. The mode is 644 and the directory is in the variable web2c subdirectory. and the proper engine is high-tech. Now that we have a format and an executable, to continue the example, we can run KTech on KTech and have KTech produce its own documentation, which, no surprise, looks as before. If you want to run LaTeX, you create the LaTeX format by running KTech on *latex.ltx. We rename latex.format to klatex.format and install it as before. Here you have a short summary of what we have just seen. The toolchain is indeed quite simple, using only standard programs. One advantage of source code is, of course, that it is easy to modify. I open the sources with my editor, and let's suppose you need more memory. So I locate memmax, and it looks like we have about 5 megawords. Let's make that 50 megawords. And the text right here tells me that I have to change memtop as well. So let's look for memtop and add another 0 here. I store the file. Run again ctangle. Run gcc again. And I have a new executable. Now let's have a look at the most important aspect, debugging. As an example, we look at a debugging session for the hint viewer for Windows. The program has a backend consisting of 3 literate programs written in cweb, a user interface written in C, and a renderer for performance written in OpenGL so that it can run on the graphics card. And I use Microsoft Visual Studio for program development. I start Visual Studio and run the viewer in debug mode. I will show you here the search feature. The word that I want to find in this dummy text is the word difficult. The word is found and marked in red. There is a slight difficulty here because the word contains the FFI ligature, which should match the search string just containing 2 F and an I. Fortunately, TeX retains the characters that are replaced by the ligature inside its ligature node, so matching can be done without major problems. Things get more difficult if we force TeX to hyphenate the word. So let's make the window a bit smaller. The ligature has now been replaced by an F and a hyphen, a line ending, a baseline skip, and an FI ligature. And the match is still found. How is that done? TeX has inserted a discretionary break just before the FFI ligature. If TeX breaks the line at that position, the replace count, here 1, will cause one character, the FFI ligature, to be deleted. Then the pre-break list with the F and the hyphen will be inserted before the break, and the post-break list with the FI ligature will be inserted after the break. To enable matching, this already complicated procedure has to be modified. An ignore node with info equal to 1 is added at the beginning of the pre-break list, and instead of deleting the FFI ligature, it is retained in the ignore node. And another ignore node with info equal to 0 is added at the end of the post-break list. When the search algorithm finds the first ignore node, it can use the list with the FFI ligature for matching just as before, and then skip everything until the second ignore node. The insertion of the ignore node is done in the post-line break routine, which comes into play after all the breakpoints have been found. To debug it, I insert a breakpoint in the post-line break routine. Now I force re-execution of the line breaking by changing the window size. And the program stops at the beginning of the routine, showing the source code of TeX. You can inspect variables like the final widow penalty, which is also shown as a local variable. But we are interested in the code that comes further down here. Where it says modify the end of the line, and specifically in the handling of the disk node. So I put another breakpoint here and tell the program to continue. It stops right here, and the next thing is change discretionary to compulsory. So we step right into that. The source window now shows the change file, where TeX code on top is replaced by the new code. I move the source to the right and step through it. Get the pre and the post break list, then the replace count, which is 1, shown also with the locals. I can set watch points displaying the memory at Q and so on. The discretionary node is changed now into an ignore node. We jump to keep the T nodes, which replaces the destroy the T nodes following Q, and put the list into the ignore node. We create the second ignore node, and we might step into the get node function. Which brings us back to TeX. Inspect rover, step out of the function, and transplant the post break list we transplant the pre-break list in the regular TeX code. We let the program continue. Now I turn to the next question. How is something like KTech or the backend of the hint viewer actually made? The process starts, of course, with the web sources of TeX. Then you can apply web change files, for example, to get the extended features of TeX. Then you can apply future changes, for example, to enlarge TeX constants, before you start the conversion process to cweb. The conversion itself is done in 2 steps. Systematic changes are done by running web2w, the converter, and individual changes are done by editing the result and conserving the edits in the ctech patch file. Further modifications of the cweb code can be done with cweb change files. For example, using the kpath search library is done this way. And for using TeX code as part of a larger project, web2w provides means to extract code that can then be linked in, as we have seen it in the case of the hint viewer. There are many variations of this process. Let's look at some of them. The simplest incarnation is ctech. It's as close as possible to Don Knuth's original program and a fully functional implementation of TeX. It's a good starting point for your own experiments. If you need the extensions of TeX, simply apply the etech change file before the conversion and apply the ectech patch file to get the necessary individual changes for TeX. If you need 64-bit memory words to have 32-bit pointers or 22-bit character codes, apply the TeX64 patch file. This patch needs to be applied before running the converter web2w, because web2w translates Pascal subrange types to the corresponding C standard types. For example, it depends on min half word, whether a half word will be assigned or an unsigned data type, and on max half word to decide if a 16-bit or a 32-bit integer is sufficient. Finally, cweb change files can be applied. For example, the kTeX change file adds the kpath search library and a TeX-live conformant command line to kTeX. To conclude this presentation, I want to give you a few selected examples of the systematic and the individual changes that are made by the web to cweb translator and the ctech change file to illustrate the challenges when trying to obtain true source code. Parameterized web macros have a single hash character to mark the insertion point in the macro's replacement text. Depending on the macro use, the replacement text can consist of 1 or more arguments. Here we have 3 arguments. To generate a C-style macro, the macro's use needs to be analyzed to find the number of arguments before the correct macro definition can be generated. It is not possible, however, to generate more meaningful parameter names as you would have in true source code. So simply A, B, C, and so on is used. The new version of the generator even converts macros with tail calls. If a web macro needs 2 different insertion points, the trick in web is to use 2 macros and 2 argument lists, and to call the second macro at the end of the first macro. Here, character info takes 2 arguments, font F and character C. The first macro inserts f as index to car base, and the second macro adds the character c. With a C-style macro, this can be done with a single macro taking 2 arguments. What are individual changes? For example, eliminating the one and only occurrence of a non-local goto, or replacing the \l, which is defined in the web macro package, but not in the cweb macro package, by the usual \le. Occasionally, a single character, here the minus, needs to be a single character string. The use of a colon as a separator in a file path is no longer in common use, so it's better to use a slash. I hope I could give you an impression of what goes on behind the scene when generating cweb source code for TeX. Thank you.
Thank you, Martin. Are there any questions for Martin about his talk or the hint format?
Too much technical detail. I know this is a talk who is possibly more interesting to the implementers, but those that just use TeX might get a glimpse of what is going on behind the scenes. And the main point here is that you can have a TeX system that allows you to experiment. If you want to program, you get something that is really very simple to get up and running and inspect. I know that there are wizards out there that find bugs in TeX just by looking at the source code. That was never possible for me. And I need a debugger to see TeX running. And that helps me understanding what TeX does in all the details. And using a system like the cweb source code, you can look at the running TeX program and get a feel of what's going on under the hood. So I recommend that as an experience for the TeX user who is also a programmer.
Yes, I have that experience myself. It's very interesting. There was a question in the Q&A section. Did you see it, or should I read it out for you?
I just had one in the chat. Is web only applying to C programming language? Well, a web basically is a literate program with snippets of Pascal code, and the translator that I have written translates a web file to a cweb file, and a cweb file is a literate program that uses snippets of C code. So basically you get, when you run ctangle on a cweb file, you get C code, which you can easily link with most other programming languages. For instance, with the Android version of the hint viewer, we link the code that we have extracted from TeX, for instance, to do the line breaking, with the Java code that is under Android used to write the user interface. So you have a program that's basically Java and linked together with C code. That's easily possible. And C is a language that you find very useful with all kinds of other languages like Python or Java and so on.
Thank you. Any more questions? Well, in that case, thank you again, Martin. And the next talk is programmed in 15 minutes. So I think we're just going to take a 15-minute break before VEET starts.